Okay, now good evening. Now today we will talk about the questions I distribute on the 12th of the March. Now please look at the question. Figure 4 shows a vertically inverted right circular conical container, and the base radius and the height of the containers are 16 cm and 30 cm respectively. You can see it's shown in the figure. There is some water of the depth 9 cm in the container. Now A, express the volume of the water in the container in terms of pi. Now please look at part A. In case the first one we are going to find is that the base radius about the volume of the water. Now we can use the similar one, so let's draw it. (13 cm), 16 cm, and then 9 cm. Okay, we have the triangle. We have the similar triangle, the smaller one and the bigger one. You will see the similar. So we let R be the base radius of the water in container. Okay, let R be the base radius of the water in container. Okay, now we will use the similar triangle. For R related to 16, so we have R over 16, and for 9 related to 30, so we get 9 over 30. So we got R equals 4.8 cm. Okay, we have this one. Maybe we better write down cm here. Okay, so it makes it easier to understand. So this is the R we are going to find. We use the same triangle R, 9, 16, 30. Okay, we found the R is equal to 4.8 cm. Now we are going to find the volume of it. That is volume of water. That is 1/3 times pi times 4.8 square times 9. This one. 1/3 times pi times 4.8 square times 9. That is 69.12 pi cm cube. We have this one. 69.12 pi cm cube. So this is the part A. And for part B1, we are going to find the area of the wet surface. We have the R is 4.8 cm. We have the 9 is the height. Now we're going to find the slant height. What's the meaning of wet surface? That means the surface was touched by water. That means we are going to find the curved surface area of the cone of the water inside the container. It is much better for you to understand. So let's have B1. B1, let L be the slant height of water in the container. We have L square equals 4.8 square plus 9 square Pythagoras theorem. And without loss of generality, L square will equals to 104.04. Take the square root. You see L equals 10.2 cm. Okay, we have this. So the wet surface. V equals to pi times 4.8 times 10.2. That will be 14.896 pi cm squared. So we have this question. Now I will stop it about 30 seconds. So please take a look. Okay, now let's look at part B2. There is another vertical inverted circular conical container of base radius 24 cm and the height 45 cm. This large container has the same volume of the water as that inside the container in figure 4. Is the area of the wet curved surface of the large container greater than the area found in B1? Express your answer. Now, let's have a look. Okay, now for the questions, we are going to check. What we are going to do is, first of all, if they are similar, the water inside must be equal. So let's check, are they similar? First of all, B2. The ratio of R2H for the first container is 16 cm to 30 cm. That is 8 to 15. Okay, we have the ratio of R to H for the first container. That means the container in part A and part B1. Okay, now check the other one. The ratio of R to H for the new container is 24 cm to 45 cm. Once again, that is 8 to 15. We have these two. Because the ratios are equal, that means they will have same area of the wet curved surface. So the claim is not correct. Okay, we have this one. Because they are similar, that means the volume of water, when we put in one vessel to the other container, we will get the same volume with the same radius and the same height immediately. In case you can check, 4.829 is also 8 to 15. So we will see the ratio are equal. Now I will stop here. So please take a look. Okay, this is the end of this question, so please pay attention. About the A, you know how to do the similar. B, you know how to use the Pythagoras theorem. and C. You know, if they have the same ratio, you will see they get the same volume and the same wet surface. For the same, if they have same volume of water. Okay, please pay attention.